Ladies and gentlemen, we are facing a silent public health crisis. The culprit? Neurotoxic heavy metals like lead and mercury. The challenge? We have been largely blind to its presence until it's too late. The damage it causes to neurological development, especially in children, is irreversible. For decades, our primary defense has been slow, expensive lab tests, creating a critical gap between exposure and knowledge. But today, that gap is closing.
Today, we are announcing a paradigm shift in environmental health monitoring.
The breakthrough lies not in a new chemical, but in a new function for one of life's most fundamental molecules, DNA. We have moved beyond DNA as a passive blueprint. Scientists have engineered what are called DNAzymes, catalytic DNA molecules that can perform specific chemical reactions. Think of them not as data storage, but as molecular machines. The key discovery is the ability to engineer this machine's active site to be exquisitely specific. We can design a DNAzyme whose structure is perturbed only by the presence of a single specific ion, like a lead ion, Pb2+. This solves the century-old problem of selectivity in environmental testing. So, how does it work as a sensor? The principle is elegant. We tether the DNAzyme to a surface and attach a silent reporter molecule. In the absence of the target, the system is dark. It is silent, but when a lead ion enters the binding pocket, it induces a self-cleavage event. The DNAzyme literally cuts itself, releasing the reporter and generating a signal, a flash of light. The public health implications of this are profound. By immobilizing these DNAzymes on a simple, low-cost test strip and pairing it with a portable electronic reader, we enable real-time, on-site, and quantitative detection. This technology can be deployed in schools, daycare centers, and homes. It empowers communities and officials to identify lead service lines and plumbing instantly without waiting for lab results. Monitor the effectiveness of filtration systems continuously. Conduct widespread, affordable screening of water sources, protecting our most vulnerable populations. This is a transition from a reactive to a proactive public health model. We are no longer waiting for the poison to do its damage before we sound the alarm. We are placing a silent, vigilant, and intelligent sentinel at the front lines. This discovery, published in the Journal of the American Chemical Society, represents a new frontier where synthetic biology and environmental health converge to create a safer, healthier world for everyone. If you think that's cool, hit that like button and subscribe.